Are the heavenly bodies of the sun-based framework the result of a visit from an unfamiliar star? The most recent discoveries suggest that billions of years ago, a heavenly visitor flew so near our home system that it steered thousands of tons of little heavenly bodies. Furthermore, potentially some of them were pulled out of their trans-Neptunian orbits and flung into the inner solar system, where they were eventually caught by the enormous gas giants as moons. However, that is not all. Another exciting hypothesis is currently advancing: the possibility that our home system was shaped in part by a close encounter with another star. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yes, and then what? When we consider our solar system, we often assume that it ends at the peripheral known planet and, accordingly, at Neptune. However, this thought doesn't correspond to cosmic reality, since, as a matter of fact, far beyond the orbit of Neptune, there are two similarly remote and broad regions, the Kuiper Belt and the Oort cloud. These are believed to be the places of origin of comets, and Suzanne Fair from the Jülich Research Center knows that this is by no means a sparse collection of celestial debris. On the contrary, several thousand of these trans-Neptunian objects have now been found. However, every now and then, data is also linked to a higher-level mystery. Thus, it happens that the unconventional orbits of these objects, which are slanted relative to the planetary plane, have for a long time been a perplexing problem. Luckily, we now have the technology to settle the inexplicable problems of our time. More specifically, Fair and her partners from the University of Leiden in the Netherlands conducted more than 3,000 virtual simulations to uncover the cause of the unusual orbits and to determine whether the odd orbital qualities of the trans-Neptunian bodies could be traced back to the influence of another star. They were successful. The key conclusion for the astrophysicists was that a single close flyby by a celestial visitor is indeed capable of explaining the oddly slanted and erratic orbits of the trans-Neptunian bodies. This even applies to those objects that are, to our knowledge, far away. For example, the dwarf planet Sedna, discovered in 2003, comes surprisingly close to the Sun on its journey through space. To recap, 1 astronomical unit is the typical distance between the Sun and the Earth, or about 150 million kilometers. The orbits of those objects that follow paths almost perpendicular to the planetary orbits can also potentially be explained with the help of a close stellar flyby. Anyway, this applies to the heavenly bodies 2008 KV42 and 2011 KT19, which made cosmic headlines after their discovery because they move in the opposite direction to the planets, closer to the Sun than Voyager. But how exactly did the star passage occur billions of years ago, and what did the corresponding heavenly body look like? Well, in this regard, Fair states that the nature of the present-day outer solar system can best be explained by the flyby of a star with a mass of about 0.8 solar masses. Moreover, the simulation showed that the star passed at an angle of about 70 degrees to the planetary plane and at a distance from the Sun of around 16.5 billion kilometers. In other words, the stellar visitor was closer to the Sun than the 2 Voyager spacecraft are today. In fact, Voyager 1 and 2 have now climbed to 2,465 and 2,061 billion kilometers away from our home star. And, as is well known, they are now exploring the mysterious realm of interstellar space. This fact is even more surprising when we consider that the twin spacecraft, which are identical in design, launched in 1977 to study the outer parts of our planetary system. While doing this, they were also expected to add new moons to the star diagrams in the domains of the gas planets. We now know that Jupiter, Saturn, and company are sometimes joined by moons that couldn't be more foreign. Essentially, scientists suspect that our planet's moon and many other moons were formed alongside their planets. Therefore, they also orbit their planetary centers prograde, which amounts to nothing other than that they closely follow after the rotation of their planet. However, this does not apply to all natural satellites. Jupiter and Saturn are joined by an extraordinarily large number of moons that act sporadically and orbit their planets retrograde, or in other words, in reverse. In the case of Jupiter, astronomers count a total of 71 satellites that move in the opposite direction to the planet's spin, and only 16 prograde moons. For Saturn, the retrograde to prograde distribution is even 100 to 22, and for Uranus and Neptune, the ratio of irregular satellites vastly exceeds that of regular ones. But how can this be explained? How is it that we find so many moons here that differ so greatly from the normal pattern? Well, very simply, the researchers suspect that the retrograde moons didn't evolve alongside their planets. Instead, they were captured by them later. It is possible that the original home of these extraordinary companions is in the Kuiper Belt or elsewhere. However, this also means that something likely caused these heavenly bodies to lose their status as trans-Neptunian objects and become moons. What about the appearance of these moons? Well, some time ago, the answer to this question would likely have been the migration of Jupiter and the other outer planets, respectively. Jupiter, in particular, may once have passed through the early solar system like a planetary wrecking ball, completely disrupting the current structure. But, of course, Suzanne Fair also points to the celestial visit. Speculation on account of the retrograde moons. From one perspective, it's in the nature of things that a heavenly body with 0.8 solar masses would have set off tremendous gravitational choppiness. On the other hand, this suspicion moreover matches with the consequences of the virtual experiences on a fundamental level. The heavenly tumult might have launched most objects in the outer area of the solar system much further outwards, or even all the way out of our home world. But the model also showed that 7.2% of the trans-Neptunian objects were launched inwards. Exhaustively, we're talking here about up to 10 million objects of 100 kilometers in size or up to 10,000 objects bigger than 1,000 kilometers. The reality is that some of these objects were gravitationally caught by the strong gas planets and captured as moons. This speculation also agrees with the retrograde-prograde distribution referenced above. In the Jupiter region, the trans-Neptunian objects were multiple times more likely to end up in a retrograde orbit than in a prograde orbit. At Saturn, it was near 20%. And although most of the new satellites were subsequently shot out from their orbits, an adequate number of settled moons remain to make sense of the presence of the sporadic satellites today. The way that a star ransacked the youthful solar system, as we can see, the inevitable issues about the nearby planetary group don't really require various complicated answers. According to the scientists, the real interest of the star visit model lies precisely in its simplicity. After all, it's able to solve an entire series of grandiose mysteries with just a single cause. Exhaustively, anyway, this heavenly event is by no means the only one that Suzanne Fellner has already studied. She and her group found a few years ago that the youthful solar system once barely escaped a disaster and was completely changed in the process. More than 4 billion years ago, a star with a mass between 0.5 and 1 solar mass is believed to have passed through the outer edge of the solar nebula. The blasting brilliant heavenly body is thought to have moved toward our young sun to within 100 astronomical units, multiple times the distance between Neptune and the sun. As the star passed the edge of the 150 astronomical unit-wide solar accretion cloud, it tore a portion of the material there with it. Eventually, it's feasible to make sense of many idiosyncrasies of the present outer solar system against the backdrop of this heavenly strike. Despite the fact that, as mentioned, many divine bodies have already been identified, cosmic models actually propose that many more objects should be lurking beyond Neptune. In this manner, Fellner and her associates even believe that the mass of the Kuiper Belt region was reduced to around 1% of its original mass due to the flyby. Moreover, the star passage not only explains the unusual orbits and the inclination of many trans-Neptunian objects against the planetary plane but also the mass ratio of Neptune and Uranus, as well as the presence of two separate populations of divine bodies in the Kuiper Belt. According to the specialists' model computations, the likelihood of such a close heavenly flyby is 20 to 30%. Clearly, only one divine body is enough to make sense of the qualities of the nearby planetary group, from bizarre orbits to retrograde and prograde moons. While we have talked about the terms prograde and retrograde extensively today, the term diggrade has sadly been somewhat dismissed. However, if you've enjoyed our video, you should tap on the like and the subscribe button now. Please become a part of our community to stay updated from here on out. See you soon.